To a lesson with Dr. Powell. Let's take a look at how we can use sandwich swallowing to simplify this Boolean algebraic expression, which is written in conjunctive normal form. That means that it has islands separated by ands, and inside the islands we have just ors. Okay, so how are we going to do this? We're going to sandwich this expression between 0 and something else. Let's suppose if we were to try A and see if that worked, what would that be like? So we're looking at our Boolean algebra and we're quotienting it out um, by a downward arrow. So everything that's a subset of A. This is an ideal in this Boolean algebra if we're looking at the operations that I had in previous videos. Um, uh, this one right here, the symmetric difference, and this guy, so multiplication by ANDing or intersection. So we're looking at this Boolean algebra right here and our chunks, all right, that we got, and we chunk it up like this in particular way. So the 0 element of this ring is this guy, okay, this whole subgroup, so it's A and everything down below it. If we know that merging A to 0, so basically setting A to 0 in all of this, makes this whole expression equal to 0, that's the same thing as saying that P is in the same chunk as A. And if P is in the same chunk of A, the way this is set up, this chunk, A is the biggest thing, everything is below it, so it's sandwiched between it. Now if it's sandwiched between, what does that mean? That means that we can rewrite P in the following way. P and A, like intersect. So notice that if A is a superset of P, then if you intersect A with P, you're going to get down to P here because like P is a subset of A, and if you intersect, you're going to get back to P. So you can rewrite P in this way. And then if you had that, let's just think what would happen for a minute. Then this guy would be able to come in and swallow anything that's a superset of it. Like this guy contains A because it's like a union of A and something else. So if you intersect with A, this could be replaceable by A, and that could be replaceable by A. So therefore A would swallow. But we haven't really determined yet whether that is actually possible with A, and why would in the world would A be a good choice here. So let's talk about that for a minute. But that's the strategy. How can we replace these islands with simpler things, with things that are like inside of them? Okay, well, we're kind of looking to getting like complements out in the open if possible, so we can like get something turning into 0 by setting other things equal to 0. So I see lots of C, and I like to see like a C and a C complement and a B and a B complement. It'd be nice to get either the B or the C complement out in the open so we could work with it. And guess what? Let me see that A. Yeah, if A is 0, that would put them both out. I mean, I don't see like C complement with C coming out right away, but this is a good place to start. Let's just start with it. Okay, so under the assumption that A is 0, then what happens to this whole expression? Keep in mind, setting A to be 0 puts everything into chunks, but these chunks preserve these operations. And so really we can still do the operations between things after setting A is equal to 0, working kind of like a chunky Boolean algebra now, but that's okay, we can still work with it. So we have this guy, but I'll withhold the symbols here of the bars, notation, whatever, and let's just kind of look at what's happening. So we take this first guy right here, and we AND it with B, and we AND it with the complement of C here, and we have this going on. Okay, so, is this equal to 0? Can we see that right away? Well, we can just repeat the sandwich process if we want on this guy if we can't see it right off, and think it'd be nice if this guy was replaceable by something that would like come over here and and we could AND it, like if this was like if C could replace it, that would be great. In fact, let's think about that for a minute. What if not b, for instance, were equal to 0? Well, if not b were equal to 0, then this guy would be 1, and so you can kind of ignore it in here, and you get 0. See, so, my goodness, that actually means that not b itself can swallow this. So, or let's see, yeah, not b can swallow this whole thing, right? Yeah, so actually that takes not b out. So, but not b and b is equal to 0, but equivalent. You could have done the same thing with c. But in any case, you kind of get a mini sandwich swallowing thing going on right here, noticing that, let's just say that can be replaced by not b, for instance, and then you notice that this is equal to 0. So setting a to be 0 in the whole thing actually made this expression kind of with bars, if you will, in chunks, assuming that we were doing our modding out here like this. Um, but and then we get that the expression that we have is actually 0 here. That's great, because that means that A is a swallower and we were successful. So we were just checking to see if A could really swallow, and we determined that it could, because setting it equal to 0 made an expression which was equivalent to 0. We had to do a little mini sandwich swallowing right here when we were thinking about, okay, is this replaceable by something? Well, if not b is equal to 0, then that makes, then that brings c out in the open. That's a 1, and c and not, and the complement of c is just equal to 0. So yes, it worked. Okay, so we know a can swallow. So that's good. So let's go back to where we were here, up here. So we know a is a swallower. So these two guys can be replaced with a. Okay, that's awesome. Anything else that can be done? Well, you know what? I don't really see any, any other, complement pairs or anything that can really happen. These seem pretty distinct. So we really have, in this case, found a simplified conjunctive normal form. Thanks for watching.